So now we want to look at the properties of solving equations. We've got about 9 main properties, and we use some of them more than others. So let's just dive on in. The first property is the addition property of equality, and it says if you add two equal quantities, most of the time two equal numbers, to both sides of an equation, it will stay equal. So in our example over here, I would be adding 4 to get rid of that subtracted 4 to both sides of the equation, and then I would have x equals 12. So I added something on both sides, the same thing, and it gave me a new equation that was still equal. The next property is subtraction property of equality, which says if you subtract two equal quantities from both sides of an equation, it will stay equal. So what we would be subtracting in this equation would be 2 to get rid of the positive 2. So if I subtract 2 from both of the sides, I'll end up with m is equal to -8, and that's my new equation. So that was using the subtraction property of equality. The third property is the multiplication property of equality, and it says if you multiply both sides by the same quantity, by the same number, then our equation will still stay equal. So I'm going to get rid of this division here, the divided by 3, by multiplying by 3 on both, multiplying by -3, on both sides. My -3 on the left side will cancel out, and I will just have p over there. And on the right side, I'm going to have 6 times -3, or -18. The next property that I'm going to be using, I'm going to scroll this up a little bit, is the division property of equality, which says if I divide both sides by the same thing, it'll stay an equal equation. So this time, what's being multiplied is what I need to get rid of with division. So I need to get rid of this 3 divided on both sides. So Q is going to be equal to 4 divided by 3, or 1.333. Those 4 properties are the most common and the ones that we use the most, but you need to know about these other ones, and we'll still use them sometimes. The next properties are the commutative property of addition and the commutative property of multiplication. The way that I remember these is about the order. For both of them, it says that if you're adding two things, you can switch the order of your adding and it'll stay equal. Or if you're multiplying two things, you can switch the order of your multiplying and it'll stay equal. So for our example for adding, it's saying that -2 plus 5 is the same thing as 5 plus -2. And if we do -2 plus 5, we're going to get 3. If I do 5 plus -2, I'm also going to get 3. So no matter which order, it stayed equal. And for our commutative property of multiplication, it's the same deal. So 18 times -2, it's saying is going to be the same thing as -2 multiplied by 18. And 18 times -2 is going to give me -36, as will -2 times 18. The next two properties are the associative properties of addition and the associative properties of multiplication. So let's start with the associative property of addition. It says if you're adding many things, more than 2, you can group them how you want and it'll stay equal. So in the example that's here, they decided to group the 3 and the 2 together and add that first. So that means they're going to get 5 plus 4, and that'll turn into a 9 for them. But if I decided I'm adding the same numbers, 4 plus 3 plus 2, but I want to do these ones first, the 4 and the 3, that'll turn into a 7 plus 2, and that's still 9. So no matter which ones I grouped together to do first, it still gave me the same answer both times. And this property also holds when we're multiplying. So if they wanted to multiply the 5 and the 2 together first, they would get 10 times 3, and that would be 30. But that's going to be the same as if I decided that I want to do the 2 times 3 first. I'll get 5 times 6, which will also give me 30. Our last property that we're going to talk about right now is the distributive property. We've been working with this one a lot. So for our distributive property, it says if you're multiplying a number, which is talking about the one out front, if you're multiplying this thing by multiple terms, which means the m and the -5, you can multiply it by each term separately and it'll stay equal. So what it means by that is we can multiply the -3 times m and the -3 times -5, do each term separate. That'll give me -3 times m is going to give me -3m, and -3 times -5 is going to give me a positive 15. So instead of trying to multiply the -3 by the whole chunk in one fell swoop, I multiplied the -3 by each part, and it turned to -3m plus 15, and it's going to be the same thing as what is in the parentheses that we started with. So now let's look at an example of solving an equation, and this equation just has one variable, and see what properties are we going to be using when we do this. So if I'm looking at solving this equation right here, the very first thing I'm going to need to get rid of is that 3 that's in the denominator there. And right now, that's a divided by 3. So in order to get rid of that division, I'm going to need to do the opposite, and I'm going to need to multiply by 3 on both sides. When I multiply by 3 on both sides, my 3's will cancel over here, and I'll have 2x plus 4 is equal to, and on the right side I have 5x times 3. So now I took 5x and I multiplied it 3 times. I'm going to have 15x over there. The property we just used was whatever has to do with multiplying by the same number on both sides. So that, if we look back, is the multiplication property of equality. And that's kind of how I simplify it. Now, if I keep looking at this problem, I'm going to draw my line down. I have x's on both sides, and I need to move them. I'm going to move the 2x to the side where the 15x is, because if I move that 15x away, there's nothing left over there. And I want there to be something on each side. I want to get all the numbers on the left side and all the x's on the right side. So in order to get rid of this positive 2x over here, I'm going to have to subtract by 2x on both sides. When I do that, I'll have no more x's over here, and I'll have a positive 4, and then I'll have 13 x's on this side. So if we think about what property we just used, we just subtracted the same thing from both sides and got a new equation. So we just used the subtraction property of equality. Now, I almost have x by itself, but that 13 is in the way. And that 13, don't forget, is multiplied by the x. So in order to get rid of multiplication, we must do the opposite. We must divide. So I need to divide on both sides by 13. That will make these two cancel out, and all I'll have is x is equal to 4 divided by 13, which when I put it into my calculator, that told me it was 0.308, rounding to 3 digits. And if we're thinking about the property we just used, we just divided by the same thing on both sides. So we just used the division property of equality. So that's an example of how when I'm solving all these problems and I know I'm doing the same thing to both sides a lot of the time, what properties are we using as we do that? We want to be able to explain them as well.